Let's say that someone has been paying on a loan with monthly payments over time and they have decided that they are tired of having that loan and they would like to pay it off early. So we should have a way to do that. We have a formula for the payoff amount, and this is related to our monthly payment formula that we've been using. The payoff amount is going to be found by taking the payment and then multiplying by this big fraction. In the numerator of the fraction, we have 1 minus the quantity 1 plus r over n, and that quantity is raised to the negative nt, and the denominator of that fraction is r over n. The payment, I think you already know about. The rate will be the interest rate as a decimal. The n is the number of payments per year, usually 12 for us. And then t is time, but there's a twist here. In our case, where we're trying to find the payoff amount, t is the number of years remaining on the loan. And that remaining portion is the twist. So let's see how this works. Let's say that you have been paying off a loan at 5% interest with monthly payments of $230.33. The original loan was for 6 years, and then after 4 years, you decide you'd like to pay it off. What will that payoff amount be at that time? To make this happen, our payoff amount will equal, well, the monthly payment needs to sit out front. That's going to be a multiplier for us. That'll be $230.33. We'll use a big set of parentheses here to set this up. In the numerator, 1 minus the quantity 1 plus. The interest rate needs to go in as a decimal. The interest rate was 5.7%, so if you take that and divide it by 100, or move the decimal point left 2 places, you'll get 0.057 as its decimal version. Our n value will be 12 because we know we've been making monthly payments. And we'll close that quantity off and raise that quantity to the negative. N is 12 again, but t is the number of years remaining. So if we're talking about after 4 years on a 6-year loan, we have 2 years remaining. That's our t value. In the denominator of our huge fraction here, we will have 0.057 over 12 once more. Then we need to do the computation for this on the calculator. This can be a little bit sticky. To make this happen, I recommend that you figure out this exponent first. Negative 12 times 2 will be negative 24. And then we can do this in pieces. You can do the numerator, 1 minus the quantity 1 plus 0.057 divided by 12, and raise that quantity to the negative 24. You can find that answer and multiply by 230.33. Find that answer, and then divide by, I would encourage parentheses on this part, a division by 0.057 divided by 12 in parentheses. When I do this computation, I get the following. This is supposed to be dollars and cents, so I'm going to round it to the nearest penny. I get $5,212.79 to the nearest penny. So that's the payoff amount with 2 years left to go on the loan. We don't know how much the original loan was for, but we can do a little bit more analysis here. We could compare this $5,212.79 to the amount of money that we would have paid if we had continued to pay for those next 2 years. So let's check that out. If we had made, let's see, 24 more monthly payments of, let's see, they were $230.33. We would have paid well, to figure that out, We need to do 24 times 230.33. That would have been a total of $5,527.92. Since we paid things off early, we saved ourselves a little bit of money. Let's see how much more that is. I'll leave a blank there. This is a certain amount more than paying the loan off early. Let's see, 55.27 and take off the $5,212.79. Do that subtraction. You can't see that part, oh no. So backing up a little bit, we were looking for how much more this continuation of all of those payments would be than paying the loan off early. When we do the subtraction, I think we get $315.13. So by paying things off early, we are saving ourselves $315.13 just from working on finding the payoff amount 2 years early.